Jai Hind. Hello cadets. Now let's continue the image formation due to spherical mirrors with the last two ray diagrams, that is image formation due to a convex mirror. Okay. First, a few precautions that you need to follow when you are drawing the ray diagrams of convex mirror. Always remember that convex mirror usually forms a virtual image, and virtual image is formed always behind the mirror, and that is why here you have to draw the ray diagram accordingly. So suppose that you are drawing it in your register having that A4 size sheet. Okay. Now in that case, when you draw the mirror, please draw it almost or exactly at the center of the page of your notebook. That way you will not be losing or lacking the required space while you are completing the ray diagram and drawing the image. Okay. Second, so take the center of curvature, mark a point. On that, put the point of your compass, the sharp point, and draw an arc of a circle somewhat like this. This arc should come almost at the center or central portion of your page. Okay. Then mark the opaque or non-transparent surface of your mirror. Wherever you have placed the sharp point of the compass, mark it as the center of curvature. Okay. Next, when you say object at infinity, once again, object distance is very large compared to the focal length of the given mirror. Okay. So when you consider such an object which is at a very large distance from the given mirror, it can be safely assumed that whatever rays that are coming from such object, they are incident on the mirror almost parallel to each other, and of course parallel to the principal axis. So when you say object at infinity, it also means that whatever rays that will be coming from that object, they will be parallel to each other either exactly or approximately, and they will also or they can also be assumed to be parallel to the principal axis of the mirror. Now, because it is a convex mirror and we have already seen how to draw those 3-4 common rays of light in case of a convex mirror, it's quite obvious that these rays of light after a reflection, they are going to diverge like this. So when you consider such case where reflected rays are diverging, so whenever reflected rays are converging, they come and intersect at a point, form real image. Likewise, whenever reflected rays are diverging, they form a virtual image. And how do we represent or how do we find the position of the virtual image? It's where these reflected rays, when they are produced backward, wherever all of them intersect, exactly at that point, we represent, we draw or we show that a virtual image has been formed at that point. So this is how you can complete this ray diagram here. So after reflection, the rays of light are actually diverging, but they appear to be converge at the focus at F. So how do we describe this? Object at infinity, image at the focus, but now remember it is going to be a virtual image. Okay. So object at infinity, image at the focus, it is virtual, erect and point sized, that is much smaller than the size of the object. So magnification is going to be very small. So object at infinity, image at focus, virtual, erect but point sized. Okay. Now what if the object is brought near the convex mirror and it is placed at finite distance? So the object can be anywhere. It can be very close to the convex mirror. It can be a little farther away, but still at finite distance. So when we say infinite distance, what do we mean? Object distance is very large compared to the focal length of the mirror. So when we say finite distance, it means the object distance is not too large compared to the focal length of the mirror. So imagine focal length of a mirror, given say convex mirror, is 10 centimeter. Any object distance from 2 meter to 5 meter can be considered as finite distance. Also, there is no hard and fast criteria for describing object at finite distance or object at infinity. Okay, next. So, for this image formation, as usual, the very first thing you are going to draw is the convex mirror right in the middle, the central space of the page. Next, mark center of curvature and then draw the object anywhere in front of the mirror, and then again as usual, remember the image is going to be diminished, not magnified, diminished, smaller than the object. That is why you need to draw the object a little bit bigger. So draw bigger object. Next, two rays of light. Most convenient rays of light in this diagram are first one parallel to the principal axis and second one incident at the pole of the mirror. So incident here. This is your pole. So incident ray parallel to the principal axis, after a reflection it is going to diverge, but it appears to be coming from the focus. So this ray you need to produce it backward so that it intersects at the focus. The second ray of light is going to go symmetrically at the pole in this manner. So again, look at the two reflected rays. They are diverging. Both of them are diverging. Obviously, virtual image will be formed. So produce both of them backward in the form of dotted line. Wherever they intersect, you get a virtual image. You get a virtual image. So, object at finite distance, image is between focus and pole of the mirror. So, there are only two image formations in case of a convex mirror. First, object at infinity, image at focus. It is virtual, erect, point size, that is diminished or highly diminished. Object at a finite distance in front of the convex mirror, image is behind the mirror between pole and focus. Again it is virtual, it is erect and diminished, that is smaller than the object. So in a way you can say that in most of the cases, or usually, convex mirror produces erect, virtual and diminished images no matter where the object is kept, either at infinity or at a finite distance. Okay, so virtual image and erect image, or real image and inverted image. So at the end of this, after seeing all the image formations due to concave and convex mirror, there are a few generalizations that we can make in connection with mirrors. First, if the image is real, it is always inverted but on the same side as that of the object. If the image is virtual, it is always erect but it is behind the mirror, that is on the opposite side of the object. So these two generalizations you can make, but only in case of mirrors. Okay, for lenses there will be different points. For mirrors, only these two important points are valid for all conditions. That is why we say generalized conditions. Okay, all right. In next video, we will study one more concept about mirrors, that is the field of view and its applications. Okay, all right. Thank you very much.